The future of space isn't just exploration, it's settlement. We are Atlas, and through our groundbreaking take on sustainable lunar outposts, we're laying the foundation for humanity's future in space. The first mining depot developed on the lunar surface, Atlas will utilize ISRU to drastically cut development costs and enable long-term, unified, and self-sustained development of the moon and beyond. Atlas is broken into 3 phases, each of which includes key milestones that highlights growth and development. You can see our full list of system-level production goals on this table here. From humble beginnings to an industrial-level mining and refinement operation on the lunar surface, Atlas will pave the way for unified, sustainable lunar settlement.
Atlas's mission site is negative 89 degrees latitude, 220 degrees longitude, just west of Shackleton Crater. The site was chosen because of its flat slope terrain, abundant illumination, warmer surface temperatures, ample line of sight with Earth, and traversable slope terrain to its objectives in Kerr and Shackleton Crater. Both PSRs have shown evidence of ice deposits, which Atlas would look to exploit.
When spaceships land on the lunar surface, they generate plume surface interactions, or PSIs, which can damage a variety of our systems. To prevent PSIs in the first phase, we have developed a lander that can land a 30 metric ton payload from Gateway to the surface without generating dust sprays by hovering above the surface. For further phases, ISRU-based landing pads will be built to prevent PSIs.
To meet production goals, we will use molten regolith electrolysis to melt the regolith into slag, metals, and oxygen. We will then use 3 rovers for production: a surface mining rover to automatically collect the regolith required for production, an ice rover for long-range expeditions to gather hydrogen and oxygen from ice deposits, and a transport rover capable of carrying 4.2 metric tons of cargo and regolith around our base. Each habitat will be able to house 4 to 8 people, in addition to lab spaces and a greenhouse. Phases 2 and 3 will include a lighter habitat structure that uses regolith as shielding.
Phase 1 will use high-efficiency quadruple-junction solar cells and lithium-ion batteries to meet initial power needs. As demand grows, Phase 2 will introduce a nuclear fission reactor using our mining crater geometry and lunar regolith for shielding. To ensure continuous coverage of our base, we will utilize NASA's Gateway and deploy a dedicated lunar relay satellite, enabling high data rate autonomous communication. A 5G network will connect all lunar assets, and our relay system will be commercially available for other lunar operations.
The full cost breakdown for Atlas's program can be seen in this table here. Additionally, we've identified several revenue streams to help fund this program, such as investor experiments conducted in the lunar environment and selling of excess metal and propellant for those looking to settle the moon and beyond.